All right, today we're talking about multiplying binomials, and what we're going to do, like I said, is we're going to review. So do you guys remember using the, at least using the box to multiply binomials? And if you don't, go ahead and draw a box, 4 little boxes inside. And how many of you would put 2x plus 6 up top? Fine, we'll do it that way. 2x plus 6. And then you would put the 2x plus 4 off to the side. 2x plus 4. Okay. And then to find out these individual products, you would do 2x times 2x, which is 4x squared. To find this one, you do 2x times 6, which is 12x. To find out this area, or this spot, you would do 2x times 4, 8x. And to find out the last one, 6 times 4 is 24. Okay, so you know how to find those. I hope that's not too new. That's modeling binomial multiplication. And then you realize that there are like terms right here. So your final answer should be 4x squared. And then what happens when you combine those? You get 20x, and then you add 24. And that not only is your complete answer, but it's also written in a certain form. Standard form. X squared, x to the first, x to the
fourth, 0.
0. Yeah, x squared, 1.
Oh, I thought it was just
yeah, and I think that's what I graded I didn't grade your quizzes completely. I graded the first page, and there was one problem that said, all right, what type of polynomial is this, and what degree is it? It's like if I just gave you this, it's a monomial, and it has a degree of 0. 0. So that's, I think everyone took it. Yes, okay.
I didn't pick up that wrong. I got that wrong.
Okay, that's okay. It wasn't a major point, but it was there. Okay. Are you good? Sorry, you had a question? Partner? Oh, because does this have a variable? This right here. I was just talking about this right here. The whole thing is a degree of 2. You're right. All right. There's another way to do that multiplication.
Everybody was okay.
Sorry, I'm a little distracted.
Quiet.
Okay, go ahead.
I thought when we had like a variable to the 0, it made the whole thing 0.
Exactly, because there's a variable that's right next to the number, but like, because like, there's a
Well,
variable
you
next
were
to the
wrong.
number, but you can't see it because it's to the 0 power.
What she said? So, what was your question again, Elizabeth? Let me make sure I answer it. You said that,
It's like
quote, I said what? What did I say? Tell me what I said. Just do it. Say it.
Okay, here we go. If the variable has like a 0 exponent, then it's a 0, like it just equals 0.
Okay, if a variable has a 0 exponent, this equals 1. Like this right here equals 1. But what we're talking about right here, just to make sure you guys get this clarified. So I do have homework, and what's going to happen is those who are distracting are going to get more. Like it's starting off on a bad foot. But like on this one, does it have a variable? No, but it can be written as x to the 0, right? Because what does x to the 0 equal?
1.
And 1 times 24 is? It's just 24. So it's there. So that's what he said. This is second power, first power, 0 power. Okay, thank you for asking, because that maybe clarified for others.
But why isn't the second one to the 0?
Because there's an exponent of, if a variable is there, it has an exponent of 1. If it's not there, you could pretend, which is actually there, that x to the 0. I know that's kind of like, wait, but there is a variable there. Okay, this is the same problem, and I want you to write this down. You're going to do all 3 methods. I want you to write this down, and you're going to multiply the same 2, but you're going to do it a little bit differently. We're not going to do on our homework the rectangle and all the rectangles that you put in there. We're not doing that method. We're either going to do this method or the next method. And some of you are looking at this saying, nope, not for me, not going to do it. And you get to choose, by the way, this one or the next one. But you're already thinking, I don't like this. I'm here to tell you that this is a method you have done more than any other method. In fact, you do this all the time. And you actually, you like it. This is your preferred method. And you're like, I don't get it. Let's just work it out, and then I'll show you how you've done it. Okay, I have a binomial times a binomial. So this is a multiplication symbol right here. Okay, so what I'm going to do, so just follow me, write down what I put down. If you're like, I don't know what you're doing, just write it down. I'll try to explain it. 6 times 4 is what?
24.
Positive 24. Okay, you just said 6 times 4. All right, 6 times 2x. Now, you're like, what are you doing? I multiplied this 6 by the second term, and now I'm going to multiply this 6 by the first term. So what's 2x times 6? 12x. Like, okay, maybe I get that. Okay, just write it down. And then I'm going to multiply 2x by 4. 2x by 4. So what's 2x times 4? 8x. Watch this. So I put a and x. You guys notice I put it under 12x? Why would I do that?
Because you want the x's to line.
I want like terms. I want lining up. But, okay, you'll see what happens here. And then what's 2x times 2x? 4x squared. And some of you are like, no. Mr. A, you must have mistaken this method with something that we've actually done. Okay, what do you do with these two here? You just add them up. But what's right here? There's nothing. There's nothing there. Adding like terms, I should get 4x squared plus 20x plus 24. And that's your answer. And yes, we got that already. Didn't we? Didn't we get that answer? So that is the answer. And we did do it this method. And you're like, oh, I don't like this. You do like this. Let's take another problem here. And I'll show you how you've done it before. Ready? 23 times 13. Okay, write that down. We're going to do this basic math problem. Write just numbers. We're going to do this. 3 times 3. 9. 3 times 2. 6. Then I put a 0 right here. 1 times 3. Yes, 3. 1 times 2. Sorry. 1 times 2. 2. And what are you going to do with those two? You're going to add them. You're adding not necessarily like terms, but you're adding like place values. So I'm going to get 9, 9, 2.
Almost 300, Mr. A.
Yeah, almost 300. But here's my thing. Some of you said 0 was right here. Oh, yeah, there is a 0. It's a place value holder. Yep, it's right there. Now, some of you may be saying, okay, fine, we may have done that, but this is easier. Actually, it's not easier when you have to carry things. Remember how you, like if this were 3 times 4, what would you have to put? A 2 and then a 1 up here. In this method, there is no carrying. You just write straight up 12 and you would get it. So here, we're using the same method, but why do we like this method better with numbers? Why do we like it better with numbers? Because they're numbers, right? Why do we like this one here? Because you have a bunch of variables which stand for numbers, right? Don't they stand for numbers? This method right here works because this has worked for so many years. Have you guys done this before? How many times do you think you'd say you've done this?
A million.
I would say maybe a few hundred times.
4,235.
But there's a better method.
Foil. The foil. The Gucci method.
Backwards it
Oh,
says
first,
Lie
outer,
off.
inner.
Line off.
We did this last time. That's a baby name. That's what I was talking about when I said isn't there like. I just forgot.
That's okay. Okay, we did do this last year. So this method, I would say you've done maybe the second most amount of times. Okay, with FOIL, it's a nice little acronym, and each letter stands for a certain part of this problem. F stands for first.
Outer.
O stands for outer. And it can also say outside. So I might say outside, I might say outer. It's the same thing. I stands for inner. And L stands for last. Last. Two boys look like they're going to get more homework tonight. Okay, So I have these first, outer, inner, and last. Now, what I want you to do on this problem especially, because I think you can remember that, but sometimes when we're actually working out, we mix what's first mean, what does outer mean, what does last mean. So we got to make sure we keep them straight. So what I'm going to do is this. This works for binomial multiplication. And guess what you're doing today? Binomial multiplication. So this is going to work for every problem today. But if I turn the page to 7-6, which we're going to go over on Monday, we're not just multiplying binomials together, we're multiplying any type of polynomial. Binomials with trinomials. Trinomials with trinomials. And even, dare I say, 4-term polynomials with 5-term polynomials. And FOIL no longer works.
It doesn't work?
No, it should.
Should?
What about if you have 2 inner?
So maybe you like FOIL, right? You just like extend it out. But there's a problem with that. We'll see in just a moment. But that's Monday. Okay, anyway. How many terms are in the first polynomial? 2. 1, 2. How many terms in the second? 2. All right, we have 2 binomials. Now, this is what I want you to do. Somebody identify the first term of each binomial. What's the first term of each binomial? You're like, what do you mean by binomial? Well, do you remember what we reviewed all this week? What's a binomial? So you should know that. What's the first term of... Wait, what's a term? What's the first term of this binomial?
2x.
2x. What's the first term of that one?
2x.
So what's 2x times 2x?
4x.
4x squared. And if you're like, how am I going to remember that? I put this for some people. 2x and 2x are the first terms of these binomials here. So that'll help you when you look back. Like, what did I multiply to get that? Well, those two. What are the outer terms? Oh, swivel.
High swivel.
Oh, you come back swivel. Okay. I don't like swivel anymore. Okay, anyway. Outer terms. What are the 2 outer terms? That means what are the outside terms? Outside terms. 2x and 4. So if you needed that, it's 2x and 4. And what is 2x times 4?
8x.
Positive 8x. Raise your hand if you have a question. A couple girls might have a couple more problems. Okay, what are the inner terms in this problem? Sophie?
6 and 2x.
6 and 2x. And again, this is for your benefit. 6 and 2x. What is 6 times 2x? 12x. And then what are the last terms of this of these 2 binomials? What are the last terms?
2x plus 4.
6 and 4. 6 and 4. So I'll write that down. 6 and 4. That's why I wrote these down, because some people are going to say, well, the last ones are these, and the outer ones are those, all of them, or in the first terms like these. So you got to make sure you keep them straight. What we mean by first and last. So what's 6 times 4? 24. How many terms do I have?
4.
Any like terms? So I should end up with 4x squared plus 20x plus 24, which is actually what we've gotten already twice, right? How many methods have we looked at today? 3 methods. The first, the rectangular method, is good. Like, I like that for the beginning. But you're not doing any more of those rectangular boxes for tonight's homework. The other way, the way we just looked at before this one, is called the vertical format. And that one works for any type of multiplication of polynomials. And you get the same answer, which is nice. But what's nice about 2 binomials is that you can use FOIL. Someone said this spells backwards lie off. Can anyone come up, raise your hand, please don't just start blurring things, because then no one knows what you're saying. Can anyone spell not another word, because, well, there is one other word, but anyway, anything else that could be spelled with FOIL. So like someone said, lie off, right? That's something that could be made from it. Cole? Philo, or like, I think it's phyllo pastry. I don't know. That's something that... Anything else?
Folly.
Folly. Yep, folly works.
Oil.
Oil. Yep, oil.
Olaf. Okay, that's not how you
I was looking for it. I was like, how? Not philo. LIFO. LIFO.
Oh, yeah. There's like 16 different things.
Yeah, there's a lot. But notice all of those, other than philo's a pretty good one. None of them are really going to help us out. Foil's a nice one. So foil's one that we memorized to help us with binomials. Okay, that's nice. Great. Go ahead and use your, I was going to say LIFO. Use foil on this one right here. And I'm going to show you that, guys, whether you use the first, second, or third method, you're actually using this property. I'll show you guys in just a minute. So you guys just do your foil, and this is what I'm going to have you do. You don't have to write this down. I'm doing this to illustrate on the board. So this is just for me to illustrate what you're going to do. So you just do your foil, and is this some truck is delivering something or backing in? So sorry. Yeah, sorry. I'll try to block out the noise with my voice.
Tell us a ghost story.
There was a ghost who did math, and he loved it. The end. Okay.
I'm pretty sure that's how we do it. Yeah.
You got depression.
All right. What are the first terms, Jake? What are the first terms? Not what are they multiplied. What are they? 4a and 2a. And somebody else, Annie, tell me what 4a times 2a is.
8a squared.
8a squared. So for the first term, we should have gotten 8a squared. All right. Laura, what are the outer terms?
4a and negative 1.
4a and negative 1. And so what is 4a times negative 1? Negative 4a. Parker, what are the inner terms?
The inner terms are 3 and 6a.
3 and 2a, which gives me 6a, or positive 6a. Okay, great. And then Callie, what are the last terms? 3 and negative 1. And what's 3 times negative 1? Negative 3. Okay. Are there any like terms?
Yes.
Do you know something here on so far our problems, that when you multiply two binomials, what kind of answer do you end up getting? Usually. Trinomial. I would say maybe 60% of the time you're going to get that. So did Mr. A say every time you multiply two binomials you get a trinomial? No. In fact, your homework, you're going to find that out. I should get 8a squared plus 2a minus 3. I do get a trinomial, which is nice, but that's my answer. Descending order, or sorry, standard form?
Yes.
Okay, here's what you did. Yes, ma'am? Before I get there.
Why is it always in like the same type of like order with like some variable squared or variable and then a normal number?
So you're noticing a pattern, right? So I think, I don't know if it's this class or last class.
Like all of our homework is like
Back, where is it? Where's that poster? Yep, there you go. Sorry, I couldn't see it. Good mathematicians look for patterns, because there are patterns all over. Now, Sarah, you're noticing when you usually multiply these two, you get something squared, right?
and then like a variable by itself and a normal number. Like that's like that in the homework and every other example.
It's not going to be like that perfectly this time, but there is a pattern that works for everyone. Now, right now what we're doing today, and really this chapter, we're multiplying a lot. Multiplying, then dividing. Next chapter, I'm going to do this to you. I'm going to give you the answer. I'm going to say, this is the answer. You need to come up with what two binomials were multiplied. You're going to have to come up with that. You're going to come up with the problem.
So that could be like an infinite thing. Because you could get like 8 times 1, or you could get 2 times 4.
So, you know what's cool about it? Because if they're infinite, that'd be kind of hard to figure out. Like, which ones do you want? How many should I put? There's only one. One pair that's going to get me that. We'll find that out next chapter, so don't feel too stressed out about that. I'll go ahead and do your foil on this one, and
Technically, you don't have to. I mean, you won't.
You may begin. Starting now. I don't mind doing the vertical multiplication. How many of you think you're going to do that? That's fine. I'm okay with that. Just make sure you keep your signs straight and add up like terms like you normally do anyway. But yep, FOIL's nice for some. Some people just like, man, I wish I had an acronym for everything I did so I could just memorize that and know what steps. That a lot of times can work, but not everything has that. Man, not everything in life can be put on a note card.
You put your resume on a note card.
Sorry?
I said you can put your resume on a note card.
Oh, okay, gotcha. All right.
Sorry.
I just wanted to hear what you said. I didn't hear it. Didn't mean to scare you there. Yeah, sorry, Jack.
I think you going sorry the bus won't stop.
It worked. Oh, yeah. Okay, what do you get with F, Cole? So when you multiply the first terms, what do you get?
2z squared.
2z squared. All right, what do you get with O, Chelsea?
I got, for the outer, I got -16.
Negative 16z. What do you get for the inner, Braden? Negative 5z. And what do you get for the last, Elizabeth? Plus 40. And again, that pattern shows you get 4 terms, and then you can add like terms, and your final answer will be what, Josh?
I got 2z minus 11. Is it 11 or is it? I think it's negative 21.
Yeah, 21z.
Plus 40.
Plus 4. Yeah, because you had negative 16 plus negative 5. That gives you negative 21z, and then plus 40. Anything else I can combine? No. Okay, that's it. Wait, did I say distributive property?
Yeah. Actually, Elizabeth said it.
Let me honor that then. Here's the distributive property. 4 terms. All right. Didn't you do 2z times z?
Yes.
Didn't you do 2z times negative 8? And I'll put the arrows. Do you remember doing that? Okay, you did that. That's one distributive property usage. And then didn't you do negative 5 times z? And then didn't you do negative 5 times negative 8? So how many times did you use the distributive property?
4 times.
Twice. Green, the 2 green arrows means one distributive property was used, and the 2 red arrows means one distributive property was used. But you multiplied 4 times, right? You did do 4 multiplications, but distributive property twice. Yes, those are actually the same exact numbers. Now, listen to me carefully. You're like, okay, that's not cool, whatever. I didn't want to know that anyway. When you multiply a binomial by a trinomial, or 2 trinomials, you know what property is going to help you out the most? Distributive property. That's what you're going to be doing. No more FOIL, because there is no such FFOOIILL. Isn't that what you do since you have more terms? No. Oh, it's FFOOILLL. That's not going to help you because there's no acronym that can help you, but there is a property that can help you. Distributive. Oh, man, the return. Uh-oh. Just when you thought, man, I get this. I get this right here. Please read. Let me read this to you properly. And it didn't have a 1, but I put that in there. Okay, it's A minus 1.1B. Okay, you're like, that B looks like a 6. It's a B. And don't make fun of my B's anymore. Okay, then it's A plus 0.3B. But that looks like a 6. It's a B. So, Mr. A, I don't write my B's like that. I write them. Then write it on your paper the way you can remember it. I'm sorry. I know it's hard. I know it's tough.
It looks like a B.
Oh, awesome! Even better. Thank you. Bonus points.
Looks like a B.
So I told you. So that's a B and that's a B. So you got A and B.
That's what you can tell your mom.
Okay, you're going to do the same thing you did on the last problem, but you got to be careful with your decimals. Because if you don't keep track of your decimal points, you're going to get numbers that look really good, but you're going to get, instead of 3/10, you're going to get 300. Is there a difference between those two numbers? Yes, huge difference. Okay, this is what I'm going to have you do. I only need 4 of you to get it right. 4 of you to get it right. 4.
Cole, Sarah.
Nope, I get to pick, and it's random, and sorry, now I've selected 2, I've selected 4. Okay, keep working. You don't know who it is. I looked at them, don't worry. I gave them eye contact. No, I already did. Some of you are like looking at. No, I already did. It's been determined.
Do they know that you gave them options?
Yeah, they looked a little nervous when I looked at them, so I got it. We connected there. So 4 of you have to get it right. In the other class, all 4 of them did not get them right. We had 3 out of 4. I don't remember, but 3 out of 4 got it right, which is good, but I needed 4 out of 4. Can this class excel? I excel? Oh, yes. Nice. That was not planned. Wait, yes it was. Do not use that joke again. Okay, anyway. 4 of you, and I'll give you 1 more minute. Be super careful. Okay. First volunteer. Molly. When you multiply the first terms, you get? Okay, so what's A times A? A squared. All right, that's the first term. A squared. Okay, when you multiply the outer terms, Jake, you get?
0.3 AB.
Plus 0.3. You said AB. I'm good with that. You could also say BA or AB. They're both the same thing. Okay, and then when you multiply the inside terms, Laura, what do you get?
The inside?
Mm-hmm.
Negative 1.1 AB.
Good. And listen, some of you may have done this problem and you were getting, okay, you got this number AB and then this number BA, and you're like, but Mr. A, can you combine those two at the end? Yes, because they're like terms. What's the definition of like terms? Same variables with the same exponents. You're like, but that you can't do that. Would you have had the same variables with the same exponents even if you wrote this A, B, B, A? Yes. It's just in a different order. That's okay. And last but certainly not least, Sydney. Last term. So far, by the way, not to put pressure, but you're 3 for 3. Go ahead. Oh, this is where the other class went 3 for 3 too. Go ahead. Sorry, no pressure. Just want to throw that out.
Negative.
Oh, yes.
Negative 0.33 B squared.
Oh, Sydney, you got it.
Good job, Sydney.
You got
I
it.
didn't get that.
What?
Yeah.
AB.
Oh.
How'd you get AB? There's only 3.
Oh, wait. I read it wrong. No, it's okay, Sydney. I just got
4 for 4. Good job, guys. Okay. See, the pressure, it helped you. Little did she know that little stressor of 3 for 3 and the last class missing it, and she got it. All right. But listen, how many of you put 3.3? You know what happened there? You did 3 times 11. You got that, but you got to move the decimal point twice. So you got to move it twice, so it becomes 0.33, and it's negative. Okay, and then I need the ultimate final correct answer in standard form from, there's a fifth person, so I totally forgot to announce that. From Max. All right, no, quiet, because this determines what you do next. You're giving me the final answer, so this is not the final.
Oh no.
And I'm being gracious today. A squared.
Okay.
Rob, that's right there.
Blood.
Did you do it on your paper?
Yeah. No, I didn't.
Okay.
Minus.
You missed that. Did you miss that last one?
I can figure it out. So a squared minus 0.8 AB minus 0.33B.
Okay, that's it. That's the trinomial. Sorry, what's up?
Is that standard form?
Good question. Is it standard form?
No.
Max, put it in standard form.
Max, your classmates will be sad to hear that it is in standard form.
Wait, what?
Uh-oh, yep. Okay.
Everybody be quiet.
Anyone know what that means when you get to 8?
Homework?
We're almost there. Okay, stay with me. Listen, when you're doing standard form, I think what you guys are thinking of is degrees. That's not what I'm thinking of. I don't want the degrees of each monomial. I want to pick one of the variables, and in this case we picked a. What do we have? A to the?
Second.
A to the?
Or first.
And a to the? 0. This is in standard form according to A. If you wanted to rewrite it, you could technically say this first, second, and third because you have B to the second, B to the
First.
B to the.
0.
But this is one of the standard forms and it works. Don't do degree. Don't do 2, 2, and 2. It's not that. That's right.
Is it called zeroth?
Zeroth. Yeah, that's the technical name. Yeah. Yeah. All right, next. Oh. I need 15 of you to get this one right. Let's get you all in this game here.
What 5 of us don't have to?
That's up to you guys.
I'm not getting it.
She's not right. Alright, that's
Try it out first. Try it out, guys. Don't give up. You're gonna. What I would do is I identify what the terms are because sometimes it's like it seems jumbled up. 1, 2, 3, and 4. I have my 4 terms, 2 binomials, and then I think, all right, what are the first terms, outer terms, inner, and last? Multiply them out. And this is a nice problem. It's not too tough, even with the fractions. But again, 15 of you need to get it right, so yeah, no pressure on some of you. Yeah, sorry. There is pressure, and you have to deal with it now, today. Actually, you have a minute and a half.
4 minutes.
Oh! You may, but I may not answer. Because if it's like too much help, I can't. But go ahead. Might as well try.
What is 7 times?
Nope, can't do that. Cole, save your answer. I'm going to check it with you guys all together. Okay, listen to me right now, guys. If you're done and you're like kind of just waiting there, can you look on page 187 real quick? 187. At the very bottom where it says try these, numbers 13 and 14. Those are back to our quadrilaterals, but you're like, wait, how can we do it with... What did we talk about last time? Perimeter. What are we talking about today? Look at it. Find the area. And you're like, how do you find the area? You multiply for any quadrilateral the base times the height, except for trapezoid. But anyway, for these two, you're going to multiply those 2 binomials. And that's what you were doing in the lesson. Because on your homework you have 3 of those. Just multiply the 2 binomials. So I don't want you to get scared by that on your homework, but you're going to get it. All right, this is what I need you to do. Sorry. is I need you to look at your neighbors. So if you have someone to the right or left, just look real quick. Look at those answers. See if they're same, different.
Go away.
Oh.
Why is it bad that I watch it?
Wait.
63r squared plus 8b plus 1/4 v squared. RV. Yes, I went too fast. RV. Yes, RV. Okay, listen to me carefully. This is your homework. Don't be scared of it. Sorry, it's all weird. It got weird. Bye bye, Swivel.